Let me ask you this. Proof of Pythagorean theorem. Anybody know that one off the top of your head? Besides people that took Math 1C with me? Okay, so let A, B, and C be the appropriate side lengths. What do I mean by appropriate side lengths? We set that up over here, right? It means that A, B, and C are the side lengths of a right triangle, with C being the length of the hypotenuse, and C is the opposite angle, right? Okay, then let's consider the following polygon, or the following shape. Let's be quite, I hear Mike McCusker saying, use words that normal people use rather than words that weird people use. I'm like, yes, but Mike, I'm very weird. No matter. Yeah. All right, so here we go. We have this triangle, and we know that this thing is A, this thing is B, this thing is C. What's this right there? Yeah, that's the theta. And what's the theta in this case? Yeah, so I guess I should actually label it with theta, just so that we can make it really, really clear the connections between this and the law of cosines. So this is theta is equal to 90. Right, so what I am going to do in this situation is I'm going to draw the same triangle 4 times. And I'm going to try not to suck at it. Okay, here we go. Which one's the long side, which one's the short side in this diagram? So the base. So A is the long side, B is the short side. So everywhere I see a long side, I put A, and then I put B, and then I put A, B. Okay. All of these angles, what do you know about it? 90. And then perhaps we impose a little bit of notation for ourselves. Perhaps we say to ourselves, because we always want to understand what the heck we're doing with our lives, right? That's really important, to understand the ideas behind the math, not just the math themselves. Perhaps we call this thing, I don't know, alpha, and this thing beta. What do you know immediately? So consider that shape. What do you know about alpha plus beta plus theta? If I take those 3 angles, what do you know? That's 180 degrees. But we knew that theta was equal to 90, which implies what about alpha plus beta? Those are equal to 90 together. So alpha is the angle between A and C. Beta is the angle between C and B. Let's go ahead and label these. What is the length of every single one of these? C, 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 C. This thing right there, A and C, what's the angle between those? Alpha. So that's angle alpha. This one right there would be angle alpha. This one would be angle alpha. And then we have one more alpha. And now what? Beta. Yeah, alpha step, beta step. Don't listen to Kanye. Just kidding. I used to, but then things happened. All right. Let me ask you this. What do you know about alpha plus beta? Okay. Alpha plus beta equals 90. What do you know about this whole angle, starting from there and going all the way over to there? 180. So we know for sure that that's 180. And we know for sure that alpha plus beta is 90, which says what about that right there? So this thing right here now must be 90. How did you know that? Because 180 minus 90 is 90, because it's Wednesday. Right? Okay, if that's 90, could you guess what that one's going to be? That one must be 90, in which case the one up here must be 90, in which case the one over here must be 90. And what 2 objects do you see? You see square large and square small. Okay. Does that shadow bother you like it does me? No? It kind of bothers you too? Yeah, we're kindred spirits on that one. That shadow's bothering me, but okay. So we say, I guess it's just the two of us, Sam, that are special. Area of large square. What's the area of the large square? First of all, how did I know the large one was a square? All 90-degree angles, but it's more than just that it's all 90-degree angles. What else do I know about it? Yeah, what's the side length? A plus B. If it's a square, what's the area of it? Yeah, this is now a squared plus 2ab plus b squared. What's the area of the small square? That one's not too bad, right? It's just c times c. Okay. How can you get, what would you have to do mathematically to get, well, geometrically, forget mathematically, to get from the large square to the small square? What would you delete? If you delete the 4 triangles, you would get the small square out from the larger square, right? Because we're going to do that, why don't we do this? What is the area of each triangle? Well, it's 1/2 base times height. And is that clear where that came from? The 1/2 base times height thing? Sometimes we just tell these formulas without actually thinking about it. It's the area of a rectangle. Base times the height, and then you take half the rectangle. It must be the area of the triangle, right? Get mad at me because I'm talking stuff that is trivial to you all minds, right? But I think it's important to kind of do that. What you just said to me is, in order to get the area of the small square, what am I going to do? I'm going to take the area of large square and subtract 4 times what? Well, be careful. 4 times the area of the triangle. So let's go ahead and realize that not in words. Here is the verbal description of my concept image. Do you see it? It's quite intuitive. What is the symbolic descriptions associated with this concept image?
AB squared.
Area of small square? C squared. Area of large square? 2ab plus b squared minus 4 times 1/2 times ab. Well, please get mad at me because I'm insulting your sense of intellectual challenge, right? What's 4 times 1/2? It's Monday, so that must be, oh no, it's Wednesday. So that thing is 2ab, and then what would you say about positive 2ab minus 2ab? Which means what? That's the Pythagorean theorem. The statement of the Pythagorean theorem brought to you by that picture. You know, one of our presidents proved the Pythagorean theorem once? I think that should be a test for the office. Yeah. All right. Stop now. Done.